Hi students, these notes are about angles. So for this first example, we're going to look at an angle. To the right, that is a picture of an angle. An angle is made of two rays that are joined at the vertex of the angle. So we'll talk about these. So the sides of an angle, here's one side, here's the other. Those are rays. So we're going to name the rays that make up the sides. Remember, we always start naming a ray by its end point. So we have one ray that starts at B, goes through A and continues. And then we put the ray symbol at the top. The other ray also starts at B, but it goes through C. And then of course we want to put the ray symbol at the top. So those are the two sides. The vertex is where the two sides or the two rays meet, and that is always a point. Together, these two sides and vertex make the angle. So the angle itself, when we refer to the angle, we are talking about just this that's in purple. Okay, remember the sides do go on and on forever. Okay? Now to name an angle, this is very important. We are going to use a new symbol. It looks like a less than, but I put a little arc through mine so that I don't think it's a less than, because sometimes we'll be working with less thans and angles together and it can get confusing. So you put the angle symbol. For an angle that's just chilling like this one, you can name it by its vertex. So I could call this angle B. Sometimes though, there are more than one angles that have the same vertex, so you have to be a little bit more specific. In that case, you have to use 3 letters. So you're going to use, you'll put the angle symbol, you'll put the vertex in the middle, and then you'll put a point on either side of that vertex point, one from each side. So on one side, we have A. On the other side, we have C. So just like that, okay? Here, I'm going to rewrite this. So angle ABC, or I could switch the C and the A as long as the B is still in the middle and call it angle CBA. So just keep in mind, if you name it with 3 letters, the middle letter has to be that vertex. All 3 ways are acceptable. Keep in mind though, if you have more than one angle with the same vertex, you must use 3 letters to be more specific. There are also 2 parts to an angle. Well, excuse me, there are not 2 parts. So the angle itself are the black lines on the paper, but it actually splits your plane into 2 parts. So the part kind of inside the angle, like this whole area, this is called the interior of the angle. Okay? Let me choose a different color so it's a little more noticeable. We'll do red. So interior. The part kind of around or on the outside of the angle, that is called the exterior. That would be all of this part of our plane. So that's the exterior. Neither of these parts are the actual angle, but the angle itself splits the plane into these 2 sections. Example 2 says, how does this diagram differ from the one in example 1? Okay, this one involves more than one angle. There are actually 3 angles. We have the larger angle, and then we have this angle, and then we have this angle. So there's actually 3 angles. So let's go ahead and name these 3 angles. Now, since we have 3 angles, they all have this vertex P. We cannot call them all angle P because then we're not specific enough. So let's name this angle first. There are 2 ways we can name it as long as P is in the center. We can use the Q and the R on either side of P. So we could name that angle QPR, or angle RPQ. So those both refer to that one angle. Now let's name this other smaller angle. And this time we want to still use P as our vertex, but this time we're going to use R and S because those are points on each of its sides. We can name that angle one of two ways: angle RPS or angle SPR. And then for the larger angle that is made up of the two smaller angles, this is where we're going to use Q and S as the 2 points on either side of our P. So for the larger angle, we can call it angle QPS or angle SPQ. What I want you to notice is that on all 6 of these names, P, the vertex point, is in the middle of the 3 other points. Okay, it always has to be that way. So example 3, same picture. Name a point in the interior of angle QPS. Angle QPS is that larger angle, right? So let me change my color just a bit here. Here's angle QPS. Remember, the interior is all of this area. So the point that's in that area is this point R right here. Point R. Okay? Now it says name a point in the exterior of angle QPR. Let me change my color one more time. Angle QPR is right here. QPR, that's this angle. The exterior would be all of this area. So a point in that part would be point S. Okay, so we're just kind of learning how to name angles and how to distinguish them, how to find them in the picture, and to identify the interior and exterior regions. So a big part of this set of notes is the angle addition postulate. This is very similar to the segment addition postulate, where we added up smaller segments to equal a longer segment. Same thing here. We've got 1, 2 smaller angles together, they make this larger angle. If we're to add this measure plus this measure, we would get the measure of the whole angle. That's all that that's saying. You also need to know what this little M represents. M stands for measure, which refers to the actual size of the angle, which we'll talk more about in a minute. So when you don't have that, when you just have angle QPR, for example, you're talking about just the angle, but once you stick an M in front of it, now you're talking about its size. So if we're ever talking about the number of the measure, like how many degrees it equals, and we use that in an equation, we need to include that M for measure. So what this is saying, if I take the measure of angle QPR plus the measure of angle RPS, here's RPS, so this guy plus this guy, it's going to equal the measure of angle QPS, the entire thing. Okay, and that seems to kind of make sense. So we're going to be setting up some equations just like we did with the segment addition postulate. All right, before we get to the equations, let's just look at straight numbers because that'll be a little bit easier. So this says if the measure of angle PQS, so PQS, that's this angle, it has a measure, so from here to here, it has a measure of 77 degrees. Okay, and the measure of angle PQR, that's this angle, right here, it has a measure of 32 degrees. Then find the measure of angle RQS. That's basically, that's basically this angle. Okay? So if I add the 32 with the one that I don't know, here let's actually use the symbols first. If I add the measure of angle RQS plus the measure of angle PQR, that should equal the measure of angle PQS, the whole big angle. So let's just go ahead and plug in some values. The measure of angle RQS, we don't know. That's what we're trying to find. So we could call that X. Plus, the measure of angle PQR is 32 degrees. And that's supposed to equal the measure of angle PQS, which is the whole thing. That's 77 degrees. Now you might think, oh, I don't need to set up an equation for this. It's pretty obvious. I'm just going to subtract. But if you get in this habit, it'll be a little bit easier when you have expressions there rather than numbers. So to solve this equation, I would just subtract 32 from both sides. So X equals 45 degrees. And X, remember, is the measure of angle RQS. So that's its measure. Now let's throw in some expressions. So the measure of angle AOC, that's this large angle, the big one, that's 70 degrees. The measure of angle AOB is X plus 10 degrees. And the measure of angle BOC is just X degrees. So if I add this guy with this guy, it's going to equal the big guy, which is 70. So here we go. We've got X plus 10, it's one of the smaller angles, plus X, which is the other smaller angle. Together, those should equal 70. So this is the equation we need to solve. So first we're going to combine our like terms. We're going to combine those x's. 1x plus 1x is 2x. We still have the plus 10 equals 70. Now we're going to subtract 10 on both sides. 10 minus 10 is 0, so 2x equals 70 minus 10, which is 60. And then we'll divide both sides by 2. So x equals 30. Now remember, in geometry, after you solve your equation, you're usually not done. But now that I know the value of x, now I can go back and find the measure of angle BOC and angle AOB. Okay? The measure of angle BOC just equals x. Well, if x is 30, then the measure of angle BOC is 30 degrees. The measure of angle AOB is x plus 10. So I want to replace the x part with its value, which is 30, and 30 plus 10 is 40 degrees. And then we can verify 30 plus 40 does equal that 70 that they need to equal together. One thing I do want to point out right here on the x, where x equals 30, don't put a degree symbol there. Don't do that because x doesn't represent the measure of the angle. It's just the value of the variable. All right. Now this part many of you are probably familiar with, the different types of angles. So whenever the directions say to classify an angle, they're talking about what type of angle it is based on its measure or its size. So we've got acute, right, obtuse, and straight. And I'm pretty sure you guys are familiar with that. Acute angles are the small guys. They're less than 90 degrees. So they might look something like that. A right angle equals 90 degrees. So it's going to look something like that. To show that it equals 90 degrees, a lot of times we'll put that little box in the corner. That means that it equals 90 degrees. An obtuse angle is greater than 90 degrees, so it's a little bit bigger than a right angle. It might look something like this. So this measure right here is bigger than 90. And then a straight angle is equal to 180 degrees. Basically, it looks like a straight line. So I've got a ray coming out here, a ray coming out here, and then this measure right here is 180 degrees. So a straight line is equal to 180 degrees. You could also think of this as a straight angle or as opposite rays. For each of these examples, we're going to do three things. We're going to name it using our symbols. We're going to tell whether its measure is less than 90 degrees, greater than 90 degrees, equal to 90 degrees, or equal to 180 degrees. And then we're going to classify. Remember, classify is to say what type: acute, obtuse, right, or straight. So let's look at this 35-degree angle. To name it, there's a couple ways. Since it's the only angle there that has that vertex F, we could just call it angle F, or we could name it with the 3 letters. We could call it angle YFI or angle IFY. Just make sure that the F is in the middle. Its measure is less than 90. 35 is less, oops, see, I put a line through my lesson, less than 90 degrees. And because it's less than 90 degrees, we're going to say that it's acute. And so some people think that, you know, if it's less than 90, it's little, it's cute, so you can call it acute. All right, let's look at the 125-degree angle. Again, since it's the only angle with that vertex T, we could call it angle T. Or we can name it with the 3 letters, as long as T is in the middle. Angle LTC or angle CTL. Its measure is larger than 90 degrees, so we'll say greater than 90 degrees. And if it's greater than 90 degrees but less than 180 degrees, we say that it is obtuse. All right, bottom left. Because we see this little box, we know that it's a right angle, so we'll get to that in a second. But its name, we can name it by just its vertex, since it's the only angle with vertex T, or we can use the 3 letters and call it angle RTS or angle STR, as long as T is in the middle. Now back to that box, because we see that box, its measure is exactly equal to 90 degrees. And if it's equal to 90 degrees, we say that it is a right angle. The last angle, bottom right, the vertex is actually X, so we could call it angle X. Or we can use the 3 letters, as long as X is in the middle, angle NXS, which is an old band, or angle SXN. Make sure that the X is in the middle there. Its measure is exactly equal to 180 degrees because it's a straight line. And because it's a straight line, we say that it is a straight angle. So unless you're told the measure of your angles, you can never assume what size it is or its measure. The only ones you can assume are the right angle if you see that box, or a straight angle if it looks like a straight line. So we also have this definition, angle bisector, and this is very similar to a segment bisector. So basically all the things we did with segments we're doing now with angles. So it is a ray, segment, or line that bisects. Remember, that means to divide or to cut into 2 equal halves. So it's bisecting into 2 congruent angles. Congruent just means that their measures are equal. So congruent is a word we're going to use a lot in this class. Congruent, let's talk about congruent real quick. For congruent, we use this symbol that looks like an equal sign that has a little wiggle above it. So basically, it's a way to say that pictures are equal in size. So we're going to use that a lot, but it kind of just means the same thing as an equal sign, just with pictures. So let's look at example 7. If ray XZ, so let's look at our picture, X through Z, that ray, is an angle bisector. So it is cutting another angle in half, and it is the angle bisector of angle WXY. So this larger angle is being cut in half by that ray down the middle. Name the 2 congruent angles that it forms. So first of all, the angles on either side of that bisector are going to be the congruent angles, and we can show that they're congruent with equal numbers of arcs. So I could either put 1 arc in both of them, I could put 2 arcs in both of them. As long as they have the same number of arcs, that means those 2 angles are congruent or that their measures are equal. So the 2 angles that are congruent are, we've got the one on the top, which we could call angle WXZ, or we could call it angle ZXW. Just make sure that X is in the middle. We'll say that that is congruent to the angle on the bottom, which is angle ZXY, or I could call it angle YXZ, just as long as X is in the middle. So you can name those 2 angles each 2 different ways. Last 2 examples. It says ray FG, this guy right here, bisects angle EFH. So what that means is this angle EFG is congruent to this angle GFH. So those 2 angles are congruent. Their values are equal. Now let's look at example 8. We've got an expression for the measure of angle EFG, which is 5x minus 10, and we have an expression for the measure of angle GFH, which is 3x plus 25. Well, those 2 measures are equal. So we're going to put an equal sign between them. So 5x minus 10 equals 3x plus 25. So you're going to be creating these equations. Now you're going to go ahead and solve. We're going to get our x's on one side. So let's move them to the left by subtracting 3x from both sides. 3x minus 3x is 0. 5x minus 3x is 2x. Bring down the minus 10 equals 25. Now we'll move our constants to the right side. We'll move that minus 10 by adding 10 to both sides. Minus 10 plus 10 is 0, so now we have 2x on the left, and we have 25 plus 10, or 35 on the right. And then last thing, we'll divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. 35 divided by 2, we could keep it like that. If you want, we can write it as 17.5. So that's the value of x for example 8. I could go back and plug it back in to find the measure of either of these 2 smaller angles. I could even find the measure of the big angle by adding those 2 smaller angles together. All I have to do is plug in that 17.5 into the x's here. Okay, let's do example 9. Example 9, we also have an expression for the 2 smaller angles, GFH and EF. No, we don't. My bad. GFH is this smaller angle on the bottom. EFH is the whole angle. So now we're going to use that segment addition postulate. So we can say the sum of the 2 smaller angles equals the larger angle. The 2 smaller angles, we've got the measure of angle EFG plus the measure of angle GFH equals the measure of the larger angle, which is angle EFH. So now we're going to plug in what we know. The measure of angle EFG, we don't have an expression for, but that angle should be congruent to the measure of angle GFH. So this expression 3x plus 20 I can actually use for both of these smaller angles. I could even do 2 times 3x plus 20. I'm just going to do 3x plus 20 plus 3x plus 20 so I have a better visual. But if you just want to do 2 times that expression and distribute it, you can. The measure of angle EFH, it says, is 4x plus 80. Alright, so let's go ahead and solve this. We're going to combine our like terms. 3x plus 3x is 6x. 20 plus 20 is 40. And that equals 4x plus 80. Get our variables to the left side. Subtract 4x on both sides. 4x minus 4x is 0. 6x minus 4x is 2x. Plus the 40 equals 80. Move our constants to the other side, so subtract 40 on both sides. So 2x equals 40. Last step, divide both sides by 2. Running out of room here, so I'm going to come over to the side. X equals 20. All right, bring your questions to class. Good job.